Yep. So we're going to discuss in groups what variables need to be the same for this bungee to work so that there are no casualties and so nobody dies. So when you discuss as partners in your groups what variables have to be the same.
The strength of the bungee, length of the bungee,
You guys have 5 more seconds. 3, 2, 1. Okay, let's discuss as a group. You raise your hand if you have a variable that will be the same. Okay. The strength of the bungee or the flexibility of it. Yep. Why would that be important? So it doesn't snap. Yes. Yep.
The length of the ropes.
The length of the rope. Why would that be important?
So it's not like lopsided.
Yep. And why? What would lopsided mean?
One side is longer than the other.
Yep. Okay. 2 more. Yeah. Do you have it?
Speed launch.
The launch, yep, if it's too, if the speed is too fast, they probably smack the ground, right? Yeah? Good job. Did everybody hear what you said? No? Can you say a little bit?
Yeah, the weight of the people inside.
Yep, she said the weight of the people inside. So these are all good variables that we're going to talk about. So we're also going to talk about the energy. So is energy the same or different? We're going to talk about kinetic and potential energy by way of the laws of motion. So raise your hand if you've heard of these laws before, the Newton's laws. Yeah. So I'm just going to review them briefly so you guys know what they're about. So the first one basically says that an object at rest will stay at rest and an object in motion will stay in motion. So for example, if I'm throwing a ball into the air, the object will stay in the air in motion until another force interferes with it. So for example, if someone catches it, that would be another force. Or the force of gravity could interfere with it, which means it would fall down. Do you guys understand that one? Okay. The second one is about the acceleration of an object. And basically says that heavier objects take a greater force to move than lighter objects. So if you're pushing this table, then you have to exert more force than if you're just pushing a book across the table. Okay. Is there any questions about these laws? Just think about them in general when you're doing your lab, and because you'll be able to write about them in your analysis at the end. So today's lab was going to be about bungees, and this is the question we're going to be answering. So how many beans would be able to fit in a cup so that the bungee stretches and so it doesn't touch the floor? So basically you're going to be putting beans in a cup and you want to predict how many beans it'll take before the cup touches the ground. These are the materials you'll be using: a slinky, 2 meter sticks, beans, paper clips, a paper cup, and tape. So I'd like you to discuss in your groups ways you can set up this experiment using these materials.
And then drop it.
About 10 more seconds. All right, let's share out your three ideas.
What?
Okay, raise your hand if you have an idea of how you're going to set it up. Yep.
You have the meter stick, and then you put the slinky on the meter stick with tape, and then you put the cup, you like tape the cup to the slinky with tape.
How will they answer this question?
And then, because it'll answer the question, because when you put it in, like when you make that, you can put the beans in, so you can test the experiment.
Okay.
Yeah.
Is there any other ideas, or do you think you hit it head on? Put your hand on your head if you think you agree with it. Okay, good job. So you guys hit it right away. So we're gonna have you guys go get a Chromebook now, and we're gonna set up the experiment we have.